Two ideal slits S1 and S2 are a distance d apart and illuminated by light of wavelength lambda passing through an ideal source slit S placed on the line through S2 as shown. The distance between the planes of the slit and the source slit is d. A screen is held at a distance d from the plane of slits. The minimum value of d for which there is darkness at O is. So, if you see the diagram, the path difference between the waves reaching P is delta 1 plus delta 2. Delta 1 plus delta 2. So, delta 1 is delta 2 is path difference between waves after emerging out of the slits also. So, there is this path difference here is regarded as delta 1 between these two. This is regarded as delta 2. So, delta 1 is initial path difference. Initial path difference. So, that is initial path difference is SS1 minus SS2. SS1 minus SS2. SS1 is D plus D. Right angle triangle I am going to get. So, root of D square plus small d square minus SS2 is D itself. So, this is delta 1. Similarly, delta 2 is the path difference between the waves, difference between the waves after emerging from the slits. So, that path difference is delta 2 is S1O, that has to travel a larger path because it is not in line with O, so it has to travel a larger path minus S2O. S2O is obviously D, direct, capital D, whereas S1O acts as a hypotenuse for this right angle triangle. So, that should be root of d square plus small d square itself. So, net path difference is delta 1 plus delta 2, which is 2 times root d square plus d square minus d. So, this is a net path difference. Now, by binomial approximation we can solve this. So, this will be written as 2 into d square plus small d square to the power half minus d. So, this can be solved by binomial approximation. So, this can be written as 2 into 1 plus d by d whole square to the power half minus d. So, finally, by binomial approximation where you use 1 plus x to the power n as 1 plus nx, that approximation, binomial approximation is this, you finally get path difference equal to d square by d. This is the equation. Now, for obtaining dark band at O, for obtaining dark band at O, path difference delta should be 2n minus 1 lambda by 2, and that is d square by d equal to 2n minus 1 lambda by 2. So, for n is equal to 1, d square by d is equal to 2 into n 1 it is lambda by 2. So, we have to calculate the value of d here. D we have to calculate. So, d is equal to root of lambda d by 2, which is option C. This is option C.